All right, welcome back, and let's get to it. We'll continue on page 51. Well, actually 52. We just got a portion of page 51 to read, and uh, let's uh, let's continue to do our reading. The last program that we coded was the let's see, lifetime, I believe. Yeah, lifetime Java. So we're going to code again the next one, which was scope error. Okay, and we're going to use our little magnifying glass to make it a little more readable. Okay, and we're going to read just on the last portion of page 51. So let's continue there. Okay, so the output generated by the program lifetime is this one, which we already saw on my uh, terminal right there. And as you can see, y is reinitialized to -1 each time the inner for loop is entered. Even though it is subsequently assigned the value 100, the value is lost. All right, and then one last point about it. Although blocks can be nested, you cannot declare a variable the same name as one in an outer scope. For example, the following program is illegal. Okay, well, this program will not compile. All right, so there's the program. And now, of course, we're going to code it because why not? Okay. And let me see. I want to make this a little wider. There we go. And this attach or okay. So now let's go. And for the sake of clarity, let's clear this whole thing. Okay, nano. Oh my god. Why is this not typing? Okay. Scope air dot Java. Okay. This program will not compile. Okay. Class scope error. Let's create our braces. Public static void main string GS and another two. Okay. Int bar equals 1. Another scope. Let's see. Here we create. Okay. Scope, of course. Int bar equals 2. Compile. Time error. Bar already defined. All right, and let's get it done. All right. Okay, so that should be good. Let's save it. Yes, sir. Let's exit. And now Java compiled scope error. Okay, got Java. See what happens. Scope error Java. Every variable bar is already defined in method main int bar, there it is. Compile to error bar already defined. One error. So as the book says, the variable declared outside of within the main method cannot be reused and redefined within any brackets within the main method. So let's see. Okay, let's take a look. All right. Okay, so now we know that that's illegal. And now let's keep reading. So a little slow. Okay. Okay. Type conversion and casting, page 52. Okay, if you have previous programming experience, you already know that it is fairly common to assign a value of one type to a variable of another type. If the two types are compatible, then Java will perform the conversion automatically. For example, it is always possible to assign an int value to a long variable. However, not all types are compatible, and thus, not all type conversions are implicitly allowed. For instance, there is no automatic conversion defined from double to byte. Fortunately, it is still possible to obtain a conversion between incompatible types. To do so, you must use a cast, which performs an explicit conversion. Let's go up. Okay. All right. Okay. Okay. Excuse me, I gotta. Okay. Let's see. Okay. All right. Apparently the Java went into. Okay, let's do something. Okay, here we go. Okay, that's more like it. To do so, you must use a cast which performs an explicit conversion between incompatible types. Let's look at both automatic type conversions and casting. Okay, Java's automatic conversions. Oh, it's because, okay, I see what's going on here. Okay. Java, oh my goodness, why isn't this here? Hold on, let me hide this. Let's hide it. I think that's what's happening. I'm trying to scroll the page and it's scrolling the actual content pane. See, now we're back in the page. Okay, so Java's automatic conversions. Let's calm down a little bit so we can all read. Okay, there we go. Okay. All right, here we go. Java's automatic conversions. When one type of data is assigned to another type of variable, an automatic type conversion will take place if the following two conditions are met. The two types are compatible and the destination type is larger than the source type. Because I've definitely seen this is pretty cool. When these two conditions are met, a widening conversion takes place. Okay. For example, the int type is always large enough to hold all valid byte values, so no explicit cast statement is required. For widening conversions, the numeric types, including integer and floating point types, are okay. For widening conversions, the numeric types, including integer and floating point types, are compatible with each other. Okay. However, there are no automatic conversions from the numeric types to char or boolean. Also, char and boolean are not compatible with each other. As mentioned earlier, Java also performs an automatic type conversion when storing a literal integer constant into variables of type byte, short, long, and char. Mm-hmm. Okay, casting incompatible types. Although the automatic type conversions are helpful, they will not fulfill all needs. For example, what if you want to assign an int value to a byte variable? This conversion will not be performed automatically because a byte is smaller than an int. Hmm. This kind of conversion is sometimes called a narrowing conversion as opposed to a widening, as we saw before. Since you're explicitly making the value narrower so that it will fit into the target type. Okay, so let's see what's next. Page 53. To create a conversion between two incompatible types, you must use a cast. A cast is simply an explicit type conversion, and it has this general form. Parentheses target type value. Here, target type specifies the desired type to convert the specified value to. For example, the following fragment casts an int to a byte. If the integer is larger than the range of a byte, it will be reduced modulo the remainder of an integer division by the byte range. Int a, byte b. B equals byte a. So a was typecasted into the b, that is the type of variable that be, which was a byte, which is smaller than the int. A different type of conversion, let's try it here. Okay. A different type of conversion will occur when a floating point value is assigned to an integer type, truncation. Also, the point will be removed. As you know, integers do not have fractional components. Thus, when a floating point value is assigned to an integer type, the fractional component is lost. Yep. For example, if the value is 1.23, 1.23 is assigned to an integer, the resulting value will simply be 1. The 0.23 will have been truncated. Of course, if the size of the whole number component is too large to fit into the target integer type, then that value will be reduced modulo the target type, modulo the target type's range. The following program demonstrates some type conversions that require casts. All right, so let's go ahead and, okay, let's look at the program here first, and then let's go and code it. Here it is. Pretty interesting stuff. Okay, so we're going to get into our, here we go, and let's get to it. Okay, so nano is going to be conversion, is going to be the name of this class. Okay. Demonstrate casts. Okay, so class conversion. Okay. Public static void main. Let me pull this out a little further because I'm a little uncomfortable here writing. Okay. Oh my god, do you see what I did there? So easy to make a mistake. There we go. Okay. Okay, so byte equals, oh no, wait. Byte b int I equals 257 double z, for the sake of readability and to follow, to get close to the target as possible, let's do this. Okay, to the target format, right? Okay, double D equals 323.142. Okay, and let's see what's the rest. Okay, so every time I see a print statement, I always like to mark it for copying because I'm sure I'm gonna use it again more than once. Okay, and now cut and reprint. There we go. Now we have it on memory. Okay, print line. Okay, conversion of int to byte. Okay, let's close the statement. B equals, okay, byte. That's the casting right there. I is the int, which is equivalent to 257 as you're seeing on the screen. Okay. All right, and now let's put another print statement here. I and B. Okay, plus I plus space. Okay, and actually, I want to put another space here. He doesn't, but I like to. There we go. Plus. Okay. Okay, plus B. Okay. Okay, and then one more. This one says conversion of double to byte. Okay, and then B equals byte D. D is of course a double. Okay. Okay, and then another. There we go. Statement D and B plus D plus B. Okay, and I think we're done. Let's see. Yeah, we're done. Okay. All right. So okay, so let's compile the code. Oh, line 3. Okay, so we got to get back to it. Oh, here it is. Right there. There it is. This is great. Okay. Actually telling me where it is right on that line. Look at that. Actually telling me right here. Alright, so let's pull up, there we go. And he compiled successfully. Okay, so for now, let's first go to, okay, our reading. And it's the output we're gonna look for. Okay, here we go. Oops, sorry about that. Not sure why the computer's so slow. Oh, there you go. Here's the output. Okay. All right, let's run it. Okay. Nice. Very nice. I think I'm missing something here. There's 3 lines. Oh, a second. Am I going crazy? Um, yeah. Looks like there's something I didn't copy, something I didn't write. Let's see. Okay. Let's see. 1, 2, 1, 2, 3, 4. Hmm. Okay. There is 6 statements. Oh my god. I messed up so bad. Quack, quack. Alright, let's see. Alright, let's see. Let's see what we got here. Alright. And sure enough, I only have 1, 2. Okay. So 1, 2, 3, 4. Oh my god, yeah. I'm missing some 2 more. So I got to just review the code and go back to it. Okay, let's see. Hmm. I'll try to make it a single page so it doesn't. But let's make a single page so way it's a little larger. Okay, first we got to zoom in, and for some reason this is so slow. I am sorry. I don't know what's going on with the system. Oh my god. Let's okay. There we go. Okay. Okay. So now I know how to turn on and off the magnifier. Sorry about that. Let's make this larger first. Okay. And let's see where I stopped. So, hmm. Okay, let's see. System BND, okay. DMB. Okay, so DMB. 3, 4, 5, 6. So what is it that I didn't print? I'm going nuts. Okay, int type. Let's review that again. Okay, so my first. Okay. Oh, okay, that's what it is. I think that's the line right there. Three, 1, 2, 3. Okay. Mm-mm. Byte E. Okay. System printout. Okay. Conversion of double to int. Oh, double to byte. So conversion of double to int is what I missed. Oh my god. Alright, so there we go. Okay, so okay. Let me first copy this because it's gonna drive me crazy. Okay, so now okay. Here we go. Oh, okay. I int. Okay. Okay, so I'm missing one, of course, from conversion statement. That is to notify that this will happen. Is what I'm missing. So now we do this again and write. So it's int. We write d and I plus d plus space plus I, and that's more like it. Okay, that's more like it. So now we have 1, 2, 3, 4, 5, and 6. There we go. Oh my god. Okay, so let's save it. Let's exit. Let's compile it again. Okay. Hopefully no errors. Oh, of course there is an error. System.out. System. Oh, it looks like I. Oh my goodness. What did I do? Let's see. Okay, where's my error? There it is. See it? Right there. Okay. Alright. Once again. Okay, and now we are going to run it. There it is. Okay, now that's more like it. That's more like it. Okay. Let's clear it. And now let's go back to our terminal. Well, not the terminal. Our thing here. Alright, so now to keep reading. Okay, and let's here we go. Let's find the output. Oh, there it is. So now that does match the output that we were expecting. Okay. Alright, so let's go to the next page. And let's do continuous scroll because it's going to be easier to scroll like that. Page 54. And I think we've been doing this for quite a while, so I think it's time to pause so that the video doesn't cut off by itself anyway, because that tends to happen after like 30 minutes. So thank you so much, and let's do it again.